Good morning, children. Today we'll discuss about types of chemical change or chemical reaction. In your syllabus, there are four types of chemical reactions. First is your direct combination reaction. This is simple combination reaction or termed as synthesis. Next is the decomposition reaction. And third, displacement, and fourth, double decomposition reaction. But remember, in some book, that double decomposition reaction may also be termed as double displacement reaction, but you have to use this term only, double decomposition reaction. First, direct combination or synthesis reaction. A reaction in which two or more substances combine together to form a single substance. In this case, a single substance is formed and two or more substances combine. This is the combination reaction. So in this direct combination or synthesis reaction, a single substance is formed by combinations of two or more substances. In the next case, we'll learn about some examples of combination reaction or synthesis reaction. First one, when two elements combine. Combination reactions can be classified into different categories. First is when elements combine. When elements combine, for example, carbon and oxygen when combined to form a carbon dioxide, this is an exothermic reaction. When iron and sulfur combine, it will form iron sulfide. When iron and chlorine combine, they will form ferric chloride. So in these three examples, you have observed that two elements combine to form a compound. In the second category, an element and a compound combine to give a new compound. Here, one element combine with another compound. For example, carbon monoxide when react with oxygen, it will form carbon dioxide. In this case, carbon monoxide is a compound, oxygen is an element to form a new compound. So this is an example of an combination reaction of an element and a compound. And then when sulfur dioxide react with oxygen, it will form sulfur trioxide. It is an example of a compound, examples of an element, example of a compound. In the third category, you will observe that two or more compounds combine to form a single product. In this case, no element participates. In this case, two or more compounds combine to form a single product. For example, when ammonia react with HCl or hydrogen chloride gas, it will form ammonium chloride. This is an example of combinations of compounds to form a new compounds. You have learned the term about that photosynthesis is also the synthesis reaction. Then endothermic, that means heat is absorbed, which is essential for our life. It is also a combination reaction. In this case, carbon dioxide react with water in presence of sunlight and chlorophyll. It will form a glucose, C6H12O6. This is a formula of glucose and oxygen molecules. Now, in your book, two experiments are given for direct combination reaction. In the first examples, black lead sulfide when heated, in your exam observations may come. This is a good questions for your exam. What happens when black lead sulfide heated in a test tube? When black lead sulfide is heated in a test tube in presence of oxygen, it will form a white lead sulfate. Black, white. These are examples of combination reactions where color changes. Another examples, hold a piece of magnesium ribbon over the flame. It burns with a dazzling light, forming magnesium oxide, MgO, which is white in color. This is MgO is just a silvery white. Look at this experiment. This is magnesium ribbon, a pair of tongs, Bunsen burner, a piece of magnesium ribbon, watch glass. Now in this case we cut this a piece of magnesium ribbon from this ribbon. There is a magnesium ribbon, Bunsen burner, what we have discussed, watch glass. We took water here, a few drops, a pairs of tongs, and the reaction is 2 mg plus O2 gives you 2 MgO. This is a balanced chemical reactions. This is white in color. So just make a small pieces of magnesium ribbon. You have to hold this piece of magnesium ribbon with a pairs of tongs, and you have to insert in the non-luminous flame of the Bunsen burner. This is a non-luminous flame. This is the magnesium ribbon burns dazzling light. And we just took the powder in this watch glass. This is an MgO, magnesium oxide. Now, so you have observed that formations of a white powders of magnesium oxide. Next we'll observe that decomposition reaction. It is the breaking up of a compound either into elements or simpler compounds. It is just the reverse of this direct combination reaction, just the reverse. Decomposition reaction may occur in presence of heat or light, or in passage of electric current. If decomposition reaction occur in presence of heat, it will be termed as thermal decomposition. For example, when mercuric oxide heated, it will form two elements, mercury and oxygen. In the last video you have observed that this delta is used to signify the heat. If you pass the electric current through the acid diluted water, it will decompose into hydrogen and oxygen. Okay. In the next case, a compounds can break up to form two or more new compounds. Calcium carbonate breaks to produce calcium oxide and carbon dioxide. Now decomposition reaction can also produce element and compound. Step by step we'll observe that thermal decompositions of different metal compounds. The first, metal hydroxide. This table is very important for your exam. Very important. Potassium and sodium. These metal hydroxides are always stable. Not their hydroxides. They are nitrates also stable. Their carbonates are also very stable to heat. They will produce nothing. Calcium, magnesium, aluminium, zinc, iron, lead and copper, on heating of their hydroxides, they will produce metal oxides and water vapor. On heating of their nitrates also, these elements, calcium to copper, will produce their respective oxides. Calcium hydroxide when heated, calcium oxide, water; zinc hydroxide when heated, zinc oxide and water; lead hydroxide when heated, lead oxides and water; similarly copper hydroxide when heated, copper oxide and water. Mercury and silver, they on heating directly yields metal, oxygen and water vapor. So you have observed three segments of this metal, where potassium and sodium, they are highly stable. Their metal hydroxides are also very stable to heat. They will produce nothing. They will remain intact on heating. Calcium, magnesium, aluminium, zinc, iron, lead and copper, their hydroxide decomposes on heating to form a metal oxide and water vapor. Mercury and silver always form these metals and oxygen, not only for the case of their hydroxide but also their nitrates, carbonates also. In similar line, you can observe that metal carbonates, the effect of heat of these metal carbonates, sodium and potassium, their carbonates are highly stable to their heat. They will form nothing. Calcium, magnesium, aluminium, zinc, iron, lead and copper, their carbonates on heating produce respective oxides and carbon dioxides. Mercury and silver, their carbonates on heating produce metal, directly metal, oxygen and carbon dioxide. Metal bicarbonates, or their hydrogen carbonates on thermal decomposition produce respective carbonates and carbon dioxide and water. Sodium hydrogen carbonate, sodium bicarbonate produce sodium carbonate, water vapor and carbon dioxide. Similarly calcium hydroxide, on heating, calcium hydroxide produce calcium carbonate, water vapor and carbon dioxide. Magnesium bicarbonate on heating also produce magnesium carbonate, water and carbon dioxide. Next is the case for their metal nitrates. In the same pattern, potassium and sodium decomposes to give their metal nitrite and oxygen. Nitrates decompose to produce nitrite. Calcium, magnesium, aluminium, zinc, iron, lead, copper, on their nitrates on heating produce respective metal oxides, nitrogen dioxides and oxygen. Look at this, their nitrites produce nitrite, and in this case they will produce oxides, oxygen gas and nitrogen dioxide gas. And mercury and silver, they will produce metal, nitrogen dioxide and oxygen. This is the basic features of these oxides, carbonates and nitrates. So decomposition reaction, examples of decomposition reactions in our body is just the digestions of food by our bodies, and examples of a decomposition reaction in our body. A starch on actions of enzyme produce glucose. Similarly, proteins on decomposition produce amino acids, fats and oils decompose to produce fatty acids, and finally oxidized by the respiration into carbon dioxide and water. Children, today we have learned that different types of chemical reactions. Basically, there are two types of chemical reactions and their examples.